Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the periodic table. Today we will begin with lecture 13 from the course, but make sure you have watched the previous ones before viewing this one. So we are discussing the periodic properties, and in that we are going to start with another property today, that is the electron gain enthalpy. So starting off first of all with the definition, we have two terms to understand over here. The first is electron affinity. Affinity means what? Means a liking for something. And what is that something over here? Yes, that is an electron. So the affinity or the liking for an electron by an atom, that is called as electron affinity. And another term which is used interchangeably, that is the electron gain enthalpy. Enthalpy is what we've already discussed before, that is in the while we were discussing ionization enthalpy. So this is an energy change for the gain of an electron, that is called as electron gain enthalpy. And as I said, both of these terms, they are used frequently and interchangeably, but there is a slight difference in both of their meanings, which we will be discussing further in the lecture. But we will be first of all seeing the definition of electron gain enthalpy, because this is the term that is recommended by the IUPAC these days. So what is electron gain enthalpy? Well, this is the amount of energy released when one electron is added to the neutral gaseous atom to form a monovalent negative ion. So what do we mean by that is that we have a neutral gaseous atom A. To that we are adding an electron, and what is formed is a negative ion, A atom with a unit negative charge on it, that is called as the anion. Okay, so we have an anion formed by the addition of an electron to a neutral atom, and in that process an energy is released, which we are referring to as the electron gain enthalpy. Now what I said was that there is energy being released, and what you find over here at I have written is delta Heg is equal to plus minus x kilojoule per mole. So first of all, this delta Heg means the enthalpy change for Eg is electron gain. Next we have this kilojoule per mole. So this unit, this is again signifying that there is something related to energy. Okay, now this plus minus is basically what I wanted to talk about here, was that while we say that the amount of energy being released, if you remember the last lecture, the sign for delta H, this should have been negative. Why negative? Because I told you when delta H is negative, this is an exothermic reaction in which the process the energy is being released. And when we say delta H is positive, that means that this is an endothermic reaction in which the energy is being absorbed in the process, right? And now writing both of them and saying that amount of energy is being released is meaning that basically for most of the reactions you will be seeing that the amount of energy is being released. Okay, so we will be having the values for delta H to be negative, but well, there are certain cases where the delta H value will be positive. That means that we will have to supply energy to the atom to put that electron into the atom. Okay, so we are going to have delta H value as plus or minus. For example, for the electron affinity, we have a chlorine atom to which an electron is added and we form a chloride ion. So it's chlorine with one negative charge. Okay, and in the process 349 kilojoule per mole energy is released. When we see a reaction and in which the energy has been written in the product side, this means that the energy is released and the delta H value, this will be negative. So we will have delta H equal to minus 349 kilojoule per mole for this reaction. Had this been written on the reactant side, that would have meant that the energy is absorbed, the reaction is endothermic, and delta H value would have been positive. So I hope first of all these things are clear because they are going to be very important for you. Okay, so now whenever the value of the delta H, e.g., that means the electron gain enthalpy values, they are high and they are high in a negative value. Okay, so delta H value negative and that is high. This is going to indicate that the additional electron is strongly bound. Okay, and when this value of delta H, e.g., this is low negative value, this indicates that the electron is loosely bound. Okay, and then what happens when the value of delta H is positive? Well, a positive delta H value means that the element this does not have any affinity for the additional electron. In fact, we are forcing in the electron into the atom by giving the energy. Okay, so a negative value shows that the element, it has a tendency to accept the coming electron. A positive value shows no tendency for the element to welcome the coming electron. Now in this process, now you can understand that energy is released or absorbed during the addition of that one electron. So the process can be endothermic or exothermic, and for this we have an example of group 17 elements, that is halogens. So halogens, if you remember the electronic configuration, the general is going to be ns2np5, that means they are one electron short of the nearest noble gas configuration. So if they get that one electron, if they gain that one electron, they will acquire the neighboring stable noble gas electronic configuration, right? So if they are in need of one electron, they are going to gain that very easily, and that is why they have very high negative electron gain enthalpy. And now what about noble gases? So noble gases, they already have a stable electronic configuration. Adding one electron to that configuration means that the electron has to enter the next higher principal quantum number level, right? And that is going to make the electronic configuration highly unstable. So if that is going to be the case, we find that the noble gases, they do not have any tendency to accept the coming electron, and they have large positive electron gain enthalpy values, right? So we are just going to force the electron into the atom of the noble gas just simply because they do not want that electron in. So now we can say that the delta H values, the electron gain enthalpy values, they are going, where are they? Large negative values seen, they will be seen towards the upper right corner of the periodic table, just preceding the noble gases. And in the process of the addition of electron, what is being formed? An anion is being formed. In the ionization enthalpy, where there was loss of an electron, a cation was formed, and in the process of gain of electron, an anion is formed. And here reduction is taking place because reduction is nothing but gain of electrons. In the ionization enthalpy, if you remember, this was oxidation taking place because that was loss of electrons. And the units for both of them, ionization enthalpy as well as electron gain enthalpy, both being energy changes, are going to be energy units. So similar to ionization enthalpy, we have units as electron volt per atom, kilojoule per mole, kilocalorie per mole, depending upon what units we are desiring. So now let us see what is the relationship between electron affinity and electron gain enthalpy. I told you both of them are used interchangeably, but there is slight difference in their meaning. So let us understand that. First of all, again, electron affinity is just a tendency of the element to accept an electron in its atom, whereas electron gain enthalpy, this is going to be the energy change related to that acceptance of electron on the coming of an electron. So what we have is that the electron affinity, this will be equal to minus of the electron gain enthalpy values at 0 Kelvin. At higher temperatures there is going to be some change, but for that also we take approximately electron gain enthalpy being equal to electron affinity values. Okay, so what is the difference over here? That electron affinity, this is minus of delta Heg. Okay, so this means that more is the affinity of an element, more negative is its electron gain enthalpy. Okay, so I hope this is clear. More is the affinity of an element, more negative is its electron gain enthalpy. You can again understand the same chlorine reaction which we had seen in the last slide. So in this reaction, 349 kilojoule per mole, this is the energy released. So delta H value would be what? Delta H value would be minus 349 kilojoule per mole. And electron affinity, this is going to be the negative of this number. So negative of minus 349 would mean plus 349 kilojoule per mole. So you can see that this energy that is being released plus 349. So you can just write simply electron affinity to be plus 349, or if you are given the delta H values, just reverse the sign. Now, while we are talking about the negative electron gain enthalpies, this is fine. We will just be reversing the sign and writing the values. But what happens when we have the delta H values to be positive? Okay, so when the delta H values are going to be positive, this means that the value for electron affinity is going to be negative. But what we take as convention is whenever the electron affinity values they are seen to be negative, we take the value of electron affinity to be 0. Okay, so either a element has a tendency to accept electron or it does not have a tendency to accept electrons. So when there is no tendency to accept electron, we call that value of electron affinity to be 0, whatever negative number it may be for the electron affinity that is coming. Okay, so when delta H is positive, electron affinity which is coming as a negative number, we take the electron affinity to be 0. For noble gases, so we will be taking the electron affinity to be 0. Okay. Next, we have to see the relationship between the ionization enthalpy and electron affinity, or you can say the electron gain enthalpy, because you know now what is the relationship over there as well. So let us see, first of all, we have the neutral gaseous atom A. It is gaining one electron to form the A negative ion. Okay, and in the process X joules of energy is released, which is shown by the delta H values of minus X joules. Okay, next what are we going to do? First of all, you should understand that this minus X joules is delta H Eg, or you can say X joules will be the value of electron affinity over here. When this A negative ion, this loses an electron and forms A, the neutral atom. What is this process? Loss of an electron, this is going to be the what process? The process of the where we have the energy change to be ionization energy. Okay, so here this X joules of energy, this has to be given to the A negative ion so that it loses an electron and forms A. Okay, so what are we seeing over here is that these values X joules energy released and X joules energy absorbed. So we can say that the mod of delta Heg of A, this is equal to the mod of delta Hie of A negative. Or we can say that the electron affinity of A, mod of it, that will be equal to the ionization enthalpy of A negative. right? I hope this is clear to you people. Similarly, we can see this in the case of a cation as well. So a cation, this gains an electron to form a neutral atom in which minus x joules is going to be the enthalpy change, which we call as the electron gain enthalpy. And then converting A to A positive, there is going to be loss of electron, and there is going to be an enthalpy change of x joules, and this we call as the ionization enthalpy. So the mod of the electron gain enthalpy of A negative, this is equal to the mod of the ionization enthalpy of A, or we can say the electron affinity of A positive, this is going to be equal to the ionization enthalpy of A. Okay, so I hope now you understand what is the relationship between the ionization enthalpy and electron affinity, or ionization enthalpy and the electron gain enthalpy. Okay. So next, another term which we have to understand is the successive electron gain enthalpy, and this is quite similar to again the successive ionization enthalpy. The first electron, when it is added, we call that as the first electron gain enthalpy, and in that you have seen that the energy change, this can be positive or negative. Okay, so there can be absorption of energy, or it can be the release of energy. But what we see in the successive electron gains is that there is always going to be addition of the subsequent electron with the absorption of energy. Why is going to be there absorption of energy? Why do we have to provide the atom with more energy to add a further electron? Is because when one electron has been added, the inter-electronic repulsions, they increase, and because of this, the second coming or the third coming electrons, they will not be welcome, and we have to force them in now. And thus we say that the successive electron gain enthalpies, they are endothermic due to the inter-electronic repulsions. You can understand this with the example of oxygen and sulfur. Okay, so let us first of all see oxygen and sulfur. So first, let oxygen. So oxygen added an electron forming a O negative ion, and 142 kilojoule per mole energy is released. But what we see is when now this O negative ion, we want to add an electron, we have to supply 702 kilojoule mole per energy to form the O2 negative ion. Okay, so first of all, we were seeing that the energy, this was being released, and now to add the second electron, we have to add in more energy. Okay, so why is it so? Because oxygen, this has a small size, high electronegativity values, which we'll be discussing further in the course. It accepts the first electron easily to form the O negative, but when the O negative is formed, there is going to be the repulsion between the electrons present and the added electron, and hence we have to supply the energy. Similar case we will be seeing with sulfur also. From sulfur, when S negative ion is formed, there is release of energy, but when S negative added one electron to form S2 negative, there is going to be absorption of energy. So we say that the successive electron gain enthalpies, they are going to be always endothermic. Okay, so I hope all the concepts, they are clear to you. So that would be all for this lecture, and in the next lecture we will be continuing our discussion further on the electron gain enthalpy, where we will be seeing the periodic trends in the property. Okay, so if you have any doubt, please feel free to mail me at h2ochemistry@gmail.com, or else you can put that in the comment section as well. And if you are liking the lecture, just a simple request, please do click on the like link below the lecture. Click on our channel H2O just to subscribe to the channel, and also on the bell icon to get a notification as and when we put up a new lecture for you, a new course for you. So we will be meeting again for the next lecture on the periodic trends in the electron gain enthalpy. Bye bye.